Hi, I'm Eliana, and this is my work of can you sell your cheat sheet? First, I selected two examples that I don't consider like pretty difficult. Each one has their own like many steps to follow, that if you do something wrong you can get confused, or if you don't analyze correctly you can also get it wrong. So I consider that it's important to point out that both of them um, I select both of them from past exams. One that I corrected, that I got it wrong in the first quiz, I guess, and the second one that I get it right, but it's also important to like also do it again or refresh my mind about how to do it. So the first one is this one that is asking us to make the graph of this function that is given, including the x and y intercepts, and also the points where the rate of change of h is 0. For this, we're gonna use the cheat sheet, and I'm gonna explain now the process. First, the y-intercepts is pretty easy. We just give the value of 0, and we are just left with this, with the 10. So our y-intercept is at 0, 10, which is here. For the x-intercepts is also kind of easy because it's already given in here. We just switch the place of these numbers and we have x equal to 5, x equal to -1/2, and x equal to 2. So those are our intercepts, which are these three that are shown. And now for the last point that is required, that are the rate of change. To do this, we are gonna need to use the derivative, because we have a cubic function. So 3 times 2 is 6, x squared minus 2 times 13, that is 26x, plus 13, and we forgot about this. Here, now, we use the general formula to get x1 and x2. We do here all the process that is needed, that is minus b. In this case, b is a negative number, so in the formula it becomes positive, plus or minus the square root of 26 squared minus 4 times 6 times 13, divided by 2 times 6. We do all the process like is shown here until we get this, and for x1 we're gonna add these two numbers and divide it by 12. That gives us as a result 3.755, and for x2 we're gonna do 26 minus 19.07, which gives us 0.5775. These points are the rate of change where h is 0, but now we need to find the x for these, the y for these two x values. And how do we do that? We just replace for each the value of x from the function given. So here, for the first one, the value that we have for y is 18.61, and we have this coordinate that is approximate like here, somewhere there. And now we substitute for the second value, which gives us this number for y. This is the coordinate that is like somewhere approximately there. And now we draw the graph. So we have the 3 x intercepts, the y intercept, on the both points of the rate of change. We draw the graph, which is kind of like this. This is right because as is a cubic function, this is the shape that it's supposed to follow, and we just add these two because this continues that way and this continues that way from there, and there we just have the first exercise. Now for the second example that I choose, it says the demand function for cupcakes produced by Sakura is P equal to 3000 minus 4Q, where P denotes the price and Q the quantity, meaning the units. The first point says, find the level of production that will maximize Sakura's total revenue and determine this revenue. For this, we are gonna need this formula, which the revenue is equal to price times quantity. So here we have that the price is equal to 3000 minus 4 times the quantity. We do this meaning the price times the quantity, 3000 times Q, 3000 Q minus 4Q times Q, giving as result minus 4Q squared. Now that we have this formula, we now need to find the level of production. For that we are gonna need the vertex formula, which is minus b divided by 2 times a, which is this. Minus b that is 3000, divided by 2 times a, that in this case is minus 4. 2 times 4 is 8. We keep the minus divided by minus is positive, and we have as a result 375. This is our level of production. And now to find the second point, that is the revenue, we are gonna use this formula that we get here, and we are gonna replace the Q, that is this value, and that will give us our result. That is, and we do 3000 times 375 minus 4 times 3075 squared. This number gives us this result, and all give us 572,500. This is our maximum revenue, and we have already completed the point number 1. Now for number 2, it says compute the average rate of change of the revenue per unit demanded in the interval 360 and 375. For this, we already have the revenue for this value, so we need to obtain the revenue for this value. We do the same process as here, but replacing this number with 360. And we have this expression, 3000 times 360 minus 4 times 360 squared. This gives us this number, and all gives us 561,600. Now we do the next step, that is the rate of change of these two numbers, and for this we are gonna use this formula, that is y2 minus y1 divided by x2 minus x1, in that order. Or x1 is 360 and our x2 is 375. And we have it here, rate of change equal to y2 minus y1 divided by x2 minus x1. This is 562,500 minus 561,600 divided by 375 minus 360. This gives us as a result 900, and all these gives us as a result 15. If we do this operation, 900 divided by 15, it gives us as a result 60. This is our rate of change, and with that we now complete the second point that is required.